Hi, so today let's take a look at the difference between a chart and a graph in LabVIEW. They may look the same, but they are very different based on their application. So we will open a VI, we will set it up, and we'll dive a little bit deeper into it. To do that, let's create a new VI, and I will maximize the front panel. In the front panel, we right click, go to the graph section, and let's place the chart first. Now that we have the chart, let's give a method for input, and I'm going to choose the numeric pointer. Sorry, it's the slider. So this is just, it'll make it easier for us to give an input. So I'm just making the slider large, and I'm going to set the range from -10 to 10. In the chart, you have the X and Y axis. So first let's connect this. And we can use a while loop since we want the program to run continuously. And I'm going to create a control, right? So now when I run, whatever input I give here is going to be replicated in the chart, but notice that it's too fast, right? The chart is mainly used for time history. So let's open the block diagram and let's add a delay. And I'm going to give, say, maybe a 50 millisecond delay. I'm going to run. So now you can see that the time history is actually stored. So this is going to be very useful when you have data that is time dependent, say a temperature sensor. So then what is a graph? Let's open a graph. I'm going to connect the graph to the slider. So notice that we can't connect it. So the error is visible here. So what it says is that the type of source, that is this, is double, and the type of sink is 1D array, which means a graph usually is used to plot segments of data, right? So we need to convert this into an array. That is, every point must be taken and should be given to the waveform graph as a single array. So the best way to do that right now is to put this in a for loop. And you notice what has happened is it has created a small auto index tunnel, which means for every iteration, the output of the slide value is taken, it is appended to an array, and then it is sent to the graph. So let's set the number of iterations here. So I'm just going to create a constant, say I have 50 milliseconds. I'm going to say 100 iterations, so that is about 5 seconds of data. And let's just run that and see. So I can keep changing here, but after every 5 seconds, that data is captured and is displayed in the graph. So here I am not going to give any input. I should get a straight line. There it is. So again, notice that there's an auto scaling issue here. So every time I do this, the readability is affected. So to stop that, we have two ways to do that. You can check the properties of the object. So you can go to the properties and you can go to scale. You can select the y-axis and take off auto scale. Or another shortcut is you can just right click, take off auto scale. Similar, right click, take off auto scale. And I can change the axis label, and here I will change the auto scale. So now when we start, you see that the readability won't be affected. See that? So what else is a graph good for? Because again, they do serve a similar purpose to display waveform. A graph can be used when you are using, say, something to display the frequency information. So we will modify this VI. I'll keep the chart here. I'll keep this graph here. But what I'm going to do is I'm going to take off the slider and I'm going to take the for loop. So I can right click and I can, right click and remove for loop, right? And Control B to remove the wires. What I'm going to do is I'm going to create a simulated signal. So to do that, I'm going to express input simulate signal. And I'm going to create a sine wave. I'm going to say I'm sampling at, say, 1000 Hertz. That should be fine. And I want to simulate the acquisition time, right? So I have a simulated signal here. And what I'll do is I will create some controls for this. So I'm going to create an amplitude control. I'm going to create a frequency control. And I'm just going to connect this to both the waveform chart and graph. So let's take a look at this. You do notice that there is some change because that's a segment of data, and we have actually we have not given the correct size of the array. That is why you can see a movement here. So what we are doing with this is you can see that the time history is seen on the top and the bottom shows only a segment of the wave, right? So but we want to make this more useful. So say you can go for the FFT of the signal. So for that we will go to signal analysis, spectral, so here I have a few options. So I'm just going to select the result in a linear result, and I will take say the magnitude RMS should be fine, or maybe you can just set it in decibels, it's fine. And here we have an option to select the window. Now this is a whole topic on its own, and I will just hit OK. I'm going to take the signal that is coming from the simulated signal, pass it to the signal input, and I'm going to take the waveform graph and connect it to the FFT output. So now I will take off this delay, and let's clean up the diagram so it's more readable. So let's start. Notice that there is actually some issue, there's some discrepancy here, but notice that it has changed to frequency and this is our range. So what I will do is I will keep it to say 50 Hertz, right? So you can see that this is your frequency at 50, and this is what the waveform looks like, right? So here if I put back auto scaling, it works. So this is one of the main differences between chart and a graph. So mostly if you are capturing a segment of the signal or you want to analyze the FFT or the PSD, go with a graph. But if you want to get more time series data, go with a chart. So I hope that covers the difference between a chart and a graph in LabVIEW. So just a recap, charts are good for time series, graph is good for segmented data. And of course, they have more features in them you can explore under the properties menu. And there are more plots in LabVIEW that we will take a look in some upcoming videos, something like the compass plot, the intensity plot, the XY graphs, and so on. So that about wraps this one up, and I'll see you guys in the next video.